you're all doing well.
Good morning, sir.
Hey, good morning, Rahul. Welcome.
Good morning, Pawan.
Good morning, Akhil, Praveen. Thank you.
Good morning.
Good morning, friends. So today, most exciting part, guys, because always, while learning any technology, that too, the technology which is really helping us in various fields and various projects. Definitely, we have to be very cautious to capture the benefits of those kind of the technologies, and such kind of technologies belongs to the big data orientation. So in the earlier sessions, so just we have completed the big data landscape as one portion, like Hadoop related ecosystem tools. Now we are into the journey of this Spark usage and how Spark really gaining the potentiality compared with Hadoop, and how Hadoop and Spark together can be used. And only in the earlier session, we have seen some terminology and some sort of implementations in a shallow way. But in a deeper way, so just we'll try to understand how to submit the jobs and in what way we can work with Spark along with the Python, PySpark orientation. All these aspects we'll discuss in the today's session. Of course, friends, in Hive and as well as the Scoop, even in distributed file system and MapReduce, certain programmatical constructs we have seen. So, like if I'm talking about the Hive, there are certain aspects like create table, partitions, bucketing, like that we're adding. And if I'm talking about the Scoop, there are list databases, list tables, import, like that we are having some sort of constructs. Similarly, in any kind of the language, maybe Java, if I'm talking, it's a combination of the classes, object, constructors, and then we are having the swing components, listeners, okay, event delegation model, all these things. And our Spark friends actually from your engineering days or from your degree or PG days, you might have observed some sort of the components like parallel and distributed mechanisms, all those aspects. So, the main key point, the main advantage of learning these technologies is whatever the things we have seen in terms of distribution, parallelism, and as well as the speed of the program, performance, all these things you can together have a look. Okay, and that too with connected things. While studying some of the concepts, friends, maybe somewhere we may be disconnected, and sometimes there is no exact proof of concept. But our luck is due to this open source technologies and that to this giant technologies of the big data tools, we are fortunate to have those kind of the considerations, where we can make use of all the constructs in a simplest way. That is a tagline actually. To implement the complex tasks, we are having the simple constructs. Okay, any member may not have the background of Python. Maybe some people like Akhil already expressed that gratitude to me. Like, hey, Dr. Pawan, I am not having a Python kind of the background. Uh, do I need to learn separately? Exactly not, guys. Because that worry for every person, real enthusiastic and who want to really contribute to the project or company, the excitement is quite similar because that too, these technologies are now become mandatory in our toolkit. So the point here is, guys, I will introduce today all these programmatical constructs, and if you feel okay, like any difficulty, no, we need some additional components of the Python and all. So definitely, what I will do is in the next session we'll scope Python essentials for this Spark. Okay, so that in a way you can have a preview or some kind of primer kind of the session. And of course, friends, the Python complete courses we offered and recorded in our academy. So definitely those resources from academy will be sharing with you, so that you can have a complete package of the Python also. The members who are really interested to go through the complete Python package, of course, they can have a look on that. So in the meantime of the course, or else after completion of the course also, out and out. So starting from the Python variables and all the identifiers up to the level of we have given some visualization techniques, okay, up to those kind of things, NumPy, Pandas, all these constructs. Okay, but however, let me see how we are able to engage or make sure the access of these kind of the things in a simplest way. Because it's not like you should know Python or Java, any programming language, friends, because the understanding, like maybe if you are working with SQL, uh, then table, views, primary key, constraints, foreign key, probably these things are pretty simple to use. Any kind of the technology in that sense. Like SQL may be achieved with Oracle or MySQL or SQL Server and Postgre. Like that, we're having plenty of tools. The underlying assumption remains same. Similarly, no matter whether Java, Python, or C++, any programming language, if you are having skill set, then it would be very easy to jump into other constructions. And now the tagline is, you need not be a pro in each programming language, but rather you should able to make use of the existing code into our requirements. Okay, so it's humanly impossible to have proficiency in all programming languages. Uh, but even some people have the passion of, if I'm asking, some of you guys would have gone through the SQL, Python, and now you are into Spark and Hadoop tools. Definitely, those members have at least 5 to 6 different tools in their package. Okay, so don't worry, no problem. So if you are having knowledge on SQL, it's perfectly all right to learn PySpark. And if you're having knowledge in Java, it's greatly helpful to you to walk through the constructs of the Spark. And if you are even knowing Python very well, of course, we have done half. Okay, so the benefit maybe 5 to 10% vary between these three categories: SQL, Java, and Python. I said, no? So it's not like Python members can do a lot more. Of course, 5 to 10% they can, but with hard work, we can beat any kind of situation. Okay. So with this note, so just let me introduce which are all the objectives I have planned in the today's session. The very first aspect, guys. So Spark, again, some kind of the background is there, where this background helps us to understand in the earlier session also what, why, and how all these kind of things we have seen. But today we'll completely narrate. So what for Spark we are using. The second important thing is the constructs, as I said. RGD is the most important construct, and thereafter the third thing is job submission. Okay, so on top of ARM, I can submit the job, guys. And of course, on top of Spark, Spark is having its separate engine. Spark is also cluster management framework. Okay, and we are having the local mode of the submission. Okay, all these three ways will try to submit the job in the PySpark orientation, and thereafter I'll give you the narration of RDD usage, some two or three implementations we'll see, and most importantly, data frame basics. Because guys, from the next class onwards, our entire discussion is revolving around this construct only. Okay, no matter whether I'm performing some optimization or whether I'm performing some sort of user-defined functions, Okay, each and every aspect, because such a nice and flexible construct where one can venture the usage of this data frame orientation. Okay, so with this, just we are ready to start with the discussion of the Spark. Okay, so the Spark introduction, and I'm having some few points compiled for you. Just let me pick up those points. Okay, in the earlier session, if you observe, I have given some kind of the comparison, like where there is a distinction between Hadoop MapReduce execution and as well as the Spark orientation. So if in case of the Hadoop MapReduce, we need to every time store the data and handle that particular data, and four IO operations are there. But whereas if you are referencing the Spark orientation, guys, you can clearly observe here. So one simple point is rather dependent on the disk. If it is the content is available in RAM, the program or the application can easily pick up the data according to the requirement. So those things we have observed. And apart from that, next is to consolidate all these things. And in the earlier session, we have seen like some sort of Hadoop MapReduce code took some 76 or 77 minutes, whereas in case of Spark, we could achieve that particular thing in 23 minutes. And in fact, that is a basic advantage where we observed in terms of Spark and Hadoop distinction, because that time the heavy data processing is completely handled by Hadoop MapReduce only. Okay, but only the issue is there is a complaint, like it is very complex, and even now also, guys, problem is the developers struggle. We all know, because we cannot complain like this. Like I'm facing some difficulty and I'm having not comfortable with this kind of the programming language. We cannot say that, but simply by learning new things, maybe Spark or PySpark or Spark SQL, and you can avoid such kind of the complaints actually. So every programmer is intelligent in that way. Like first we started with C, CPP, and then we felt that okay, Java is pretty simple, and of course I can leverage the capacity. Like that, we jumped into Java orientation. Now Python is giving us everything, no matter which domain or which kind of the project, data science, data engineering, or all these deep learning, okay, visualizations, all these mathematical and statistical computing. So every aspect is given by Python. So we are pretty comfortable. We are not complaining on Java, but we conveniently adopt to this new Python. It's so old only, but according to the requirement, maybe Flask or Django or these kind of the framework, right? So similarly, here at that time, the Python guys also want to venture the usage of the Spark, because of the only possibility at that time. Of course, we have seen in Java and as well as the Python, we can able to implement the MapReduce code. But still, the problem remains same. Like in Java, if I am taking some 20 lines of the code, at least 15 to 16 lines I should, and more than that, guys. In fact, especially the other kind of the logics may be simple in Python, but definitely MapReduce is not that much easy compared with Java, because Java, of course, is a native of Hadoop, and the MapReduce implementation with Java is definitely better than Python frames. Reason is in terms of combiner, in terms of partitioner, all these things are only requiring one line of the code in Java. Okay, to the existing kind of the MapReduce code, I can add only one or two lines of the code in Java to scope the combiner and as well as the partitioner. But whereas in Python, guys, there is no specific a native support, because Python we are seeing the alternative, And moreover, with the predefined Hadoop streaming jar, we are trying to achieve the functionality. Okay. So these are all the aspects, guys. So where you can see that there is definitely Java overtakes the implementation of the Python. Then the Python developers that time, have left with only one option. Okay, either they should go with the Java by default, or else they should design the application in Python, and accordingly they should adopt the predefined art and all the things. Now this Spark came into existence, and of course Spark proved the running capacity on ARN also, because ARN has opened the path to integration of new techniques and technologies. So with that, the Python users also have the communication with MapReduce, ARN and MapReduce. Obviously, they also demanded we have to release the Python version of the Spark. Then the resultant is PySpark actually. Okay. Now you see. So these problems, in the sense, heavy problems like engineers develop different systems at different times. Okay, each of these systems have their own APIs and cluster configurations. So for the sake of the streaming, Storm. For the sake of the management of job submissions and visualizations and machine learning, each and every aspect is requiring one technology. Okay, so then after implementation of these kind of things, we want to integrate those things and we can submit it. This adds further operational complexity of Hadoop and MapReduce systems by default, no? Because I need to handle streaming with Storm, and if I want to perform any map machine learning kind of thing, I should use the Mahout library. So obviously, guys, MapReduce itself is causing some trouble to us. Trouble in the sense it's a complex kind of environment where everything must be think in terms of key value pair. So we felt very annoyed at that time. But on top of that, each and every aspect again, I need these supportive ecosystem tools. So the idea was to develop a single unified system. Observe here, guys, single unified system having capabilities to solve all these problems. Maybe the streaming or graph based kind of thing, machine learning and data engineering, data science, or all these kind of the aspects. So thanks to the researchers, guys, actually, these guys, makes our life easier, and especially this university members who had previously worked on Hadoop MapReduce took on this challenge with a project and they call it as Spark. Okay, guys, the surprise is the members, who designed, who worked on the projects of the MapReduce, because the one who is leading the things and who is developing the things knows the benefits and as well as the complexities. Okay, so they involved in the project called Spark. Okay, so the idea is, as I said, single unified system. Okay, the system which is having the capability of the storage, processing, parallel, distributed, streaming aspect, machine learning, all these in a single environment. Now, ideas from Hadoop MapReduce are borrowed but enhanced in the Spark project. That's what I said, friends. Without knowing, without having the background of the Hadoop MapReduce, okay, though you are studying Spark, of course, that is giving only one dimension of learning. And why we have scoped this Hive, Scoop, and Hadoop distributed file system, MapReduce. The reason is pretty simple, because on top of this Hadoop MapReduce, some of the aspects are directly inherited into the Spark development. Okay, that is the reason why there are such a similarities. Even in our architectural diagram, also you can feel the advantage. And but only the thing is, the coding wise, there is a complete distinction, guys. In case of the MapReduce, we are having a certain heavy constructs and heavy code. But Spark, what they have done is they introduced many customizations, friends. Okay, that I will, however, I will reveal and I will show you. And Spark was developed as highly fault tolerant. If someone asks you, okay, I know that Spark is a cluster management framework, but which are all the additional benefits? Okay, of course, you can answer that like highly fault tolerant, massively parallel, in memory processing, Okay, easy APIs in multiple language in unified manner. Multiple language in the sense R, Java, and we're having Python, and of course Scala. Okay, so these many languages supports. It's not that much easy, guys. Only one kind of the cluster management framework is scoping these many languages. You can easily observe how hard work the researchers would have placed. Okay, so as to give the shape to the current Spark engine. Okay, so and now by 2013, Spark had gained widespread use and popularity. Okay. So this happened just 10 years back, right? Not even 10 years, 8 to 9 years back. But from 2015 onwards, Spark is rising like anything. So almost all, you can enjoy your entire life in industry with Spark. Maybe that is your wish. Whether I can go with the Scala, I can go with the Python or R or Java. Each and every stream is having the projects, and of course, especially this PySpark is having the potential market now as of now. Okay, and of course it continues, friends, because the benefit of Python is, friends, Python itself is having some separate packages for machine learning, data engineering, and for all the generic aspects like NumPy, Pandas, Matplotlib, Seaborn, and Scikit-learn, SciPy. Like that, we're having plenty of development in that, and it is become very easy to integrate these kind of the capabilities. We can depute some of the properties from Python to our Spark implementation. So that is how we can perform. And as I said, unified, the Spark is a unified analytics engine, mainly designed for large-scale distributed data processing on-premise. Okay, on-premise in the sense, maybe if you refer, actually whatever the virtual machine we are having, that virtual machine is having inbuilt Spark engine. Okay, there itself you can run, and moreover, of course, the nowadays the companies are also designing their own data centers. They want to venture, they want to perform some kind of the research, and they want to perform some kind of activities related to the clients according to that, or in the cloud environment, like maybe that is AWS. Now we have seen the cloud era and all, and thereafter there is GCP orientation or Azure or Databricks. Okay, so these are all various things, friends, because as you see, one important thing is for any technology, if it is ready to adopt with the corresponding languages, and if it is ready to adopt with various kinds of the cloud, and that itself is a success, guys. Okay, so but Spark is having everything. Like it is simple, and you can implement your application in either Spark SQL or PySpark or Scala orientation, and then you can submit your job to AIRN or some other Cloudera kind of thing, or in the local mode or standalone mode. Like one kind of gold, I can say. The Spark is a gold mine where the programmers can dig according to their requirement. Okay, and speed, of course, proven capacity as limited disk IO, huge performance boost, run workloads 100 times faster compared with Hadoop. Okay, and ease of use. Write application quickly in Java, Scala, Python, R, and SQL. Scala is the functional programming language. Spark is completely written in the written where Scala used to completely design this Spark. And Spark achieves simplicity by providing a fundamental abstraction of the simple logical RTD. Today, our 50% discussion is related to RTD only, upon which all other higher level structured abstractions like data frames, data sets are constructed. So these data sets are belonging to Scala, guys, actually. And data frames, of course, both in PySpark and Scala, we are having the data frames. So this particular statement gives that many programming languages were there, and of course Scala. Why they are talking specifically is because of that Scala used to design this Spark, the complete Spark, and apart from that, a simple construct called RDD. okay, resilient distributed data set. So which is a core part of our Spark learning. And generally, Spark power of a stack that I will show you guys the appropriate ecosystem of the Spark, which is having the SQL construct component and as well as the data frames, machine learning library, okay, which is pretty handy for all the data scientists and machine learning engineers, graphics, Spark streaming. You can combine these libraries seamlessly in same application. As I said, within the simple application, you can perform the HDFS access and you can submit the job. And thereafter, that job submission may involve the map reduce orientation. Okay, so these kind of pipelines. So in the yesterday's session also we have seen pipeline is a logical connect between various activities and various actions related to our implementation. So this gives a kind of understanding where one can observe the benefits of the Spark. Okay. Now the entire representation, the entire thing can be shown in the diagram friends, like this. So just if you observe this diagram, see here. So what it says, just it is providing us all the narration with a simple Spark. Of course, Hadoop distributed file system. This is most important, friends. In case of the Databricks, the basic terminology is a Delta Lake actually. Okay, Delta Lake is directly connected with Spark Engine, Redis, MongoDB, Cassandra. These are all NoSQL kind of databases. Kafka, streaming, Alexio, Elastic Search. Actually, this is also nowadays gaining potentiality, friends, because according to the requirement, the appropriate network can grow or shrink. Okay, and MySQL this will pretty easy to depute any kind of thing. But generally, guys, um, however, we are enjoying with this SQL kind of the constructs completely, no matter whether I'm using MySQL or SQL Server or Oracle or whichever. And of course, HBase, which is also again comes under the category of the NoSQL, PostgreSQL. So like that, different categories of applications, okay, you can easily get and perform with respect to the Spark. But majority of users built their implementation with SQL and PySpark orientation, and that to the data frames. And of course, RDD, however, RDD is the basic or fundamental aspect. If I'm using data frames also, internally RDD support would be there. That I will reveal in a while. What is the logical connect between data frame and as well as the RDD orientation? Okay, so this is a simple diagram where you can observe the integration and capabilities of the PySpark construct. Okay, and let me consolidate all the things, guys. Okay, so just with these kind of the statements, just I'm having certain compilation for us. If you observe these points, Spark runs everywhere. That means I can submit the job on ad. Of course, Mesos is the default cluster management and standalone mode also. I'll show you how I can run local and how I can run with Spark support. Okay, without support of ARN or something. It's basically a open source kind of thing. You can straight away launch the Databricks Community Edition. In the earlier session also I have shown, or else you can go to the Apache and you can download that particular Spark built on top of Hadoop with certain versions. Okay, that directly you can venture the downloads and implementations. Scalability, because as it is working with heavy data loads, then of course scalability is the default property. Distributed. Okay, as I said, guys, if you refer the distributed environment, as it is not denying the usage of the Hadoop distributed file system, this file system itself is providing the name itself is giving the distributed environment. Okay, establishing many systems to achieve a particular functionality, which greatly reduces the time caching mechanism. So this is the main purpose of the RDD. Okay, so while dealing with that particular RDD, it provides a kind of the caching, a powerful caching. Like the most frequently accessed items will be cached, and even it is very nearest to the program compared with the RAM also. Okay, so that is how you can observe in what way Spark is achieving the benefits or fastness compared with the Hadoop tools and real time and batch. So see, batch is something like which is offline kind of execution and bulk data processing. And real time, why we are saying is as if you remember, friends, from the yesterday's session also, we have seen that our Spark is ready to handle the batch processing. It is ready to handle the interactive programming or iterative kind of the programming. All these aspects are built on a single unit. Okay, so all these actually this is a common statement: real time and batch processing. Okay, so now with this you can observe for the job submission I am having the ARI support, and for any programmer, okay, you need not pay anything. Of course, it is community edition is available, and according to your requirement, you can parallelize the jobs. Scalability is achieved, distribution and fastness with the help of the powerful caching, and processing also in terms of real and batch. Okay, in both the ways one can venture. Okay. So these are all pretty straightforward, and anyone can easily venture the aspects of that Spark. But now I'm introducing you the real stack of, okay, what exactly the stack model of the Spark. Because by understanding these kind of things, we can simulate these understanding with these considerations, friends. If you observe these things, these are all Spark core modules. Okay, the core specifies that transformations and actions. These are all the basic constructs where we are going to execute maybe our RTD or our data frame, whatever we are talking. To perform some kind of the programming, I need some kind of the transformations and as well as the actions. So friends, here observe that transformation is very lazy. As I said earlier, lazy evaluation or lazy execution. Transformation is not going to trigger whenever you write the code or submit the code. But whereas action, in the sense, maybe something it should show or it should compute, but then only the appropriate previous transformations are going to run. Assume that here I'm writing a code, and that code is having some T1, T2, T3 transformations, and finally I have used one action, one activity which is related to action. Now this particular action should be implemented, so it is going back to the appropriate transformations which are all dependent. Okay, so as to complete this particular activity, definitely I should complete the transformations. The understanding here is this: transformations are not going to run at the time of submission, but whereas whenever there is an action, maybe one, two, three, this is the fourth step. Fourth step or fourth command is the action. So until fourth command, these three commands are not going to execute it. These are lazy. Okay, but in the at the time of receiving this fourth action, Spark is automatically integrates or fires all these particular transformations, and the resultant of these particular transformations given to the action, and finally it is going to give the result. Okay, so that's what how you can prefer the core transformations and actions such as map, reduce, join, filter. Okay, I'll introduce you one by one. Don't worry about that. And they typically work on RDD and as well as the data frame. And Spark SQL is having a separate fan base, guys. Like the people who even don't run the print statement in Python, they can easily maintain this SQL orientation. Like because any computer science graduate or maybe the people who works for the projects, the basic code is SQL. The basic kind of the representation is SQL. So with the SQL kind of the knowledge, okay, completely without learning any new kind of thing, maybe Java, Python, or all the things. you can run through this Spark SQL. But one thing, friends, I want to clarify here. I don't want to bluff. See, friends, suppose if any, while running some kind of the code, if you're having proficiency of at least PySpark, then your capability and your knowledge is different, guys. Rather, of course, nothing harm with your with SQL capabilities. Also, you can try and handle the situations. But observe here, whenever any error is coming up, and if you are knowing the PySpark along with the Spark SQL, the way you handle the error is completely distinct with the member who is having only Spark SQL knowledge. Okay, that means we are having the out and out knowledge related to this implementation, especially PySpark. So PySpark, of course, allowing the Spark SQL. Okay, not PySpark is not allowing Spark itself allowing the PySpark orientation and Spark SQL. But my strong recommendation is as there is a direct impact of the RDD and as well as the data frame related to the PySpark, it is always better to have the knowledge of the PySpark also. Okay, along with the Spark SQL. Okay, so that's what the reason why we are studying both the things. I am not going to give only the Spark SQL, but along with that, we'll start with PySpark also. Okay, so that you can have multi way of doing the things. You can slowly, gradually move to this PySpark after venturing this Spark SQL. Or some people can easily jump into this PySpark without any delay. Okay, it all depends on your hard work and how you get into your projects and all. And by the way, guys, I need one help from you because a general practice after completion of the course, just I give the capstone project. Okay, just you form the groups. Okay, form the groups, and by tomorrow in a morning session, you just I will ask the groups, maybe teams. The rule is only 3 members, 3 to 4 members can form a batch or a team. Okay, based on maybe we are having some 25 to 26 members. Maybe I can say some eight. Okay, eight, maybe 8 threes or 8 fours, whatever. 8 teams, so that each team will get one project. So I'll be posting 8 projects. Okay, that project involves starting from the HDFS, which involves MapReduce, Hive, Coop, and then our Spark. Okay, I will be giving some 15 days of time, 2 weeks of the time. And I'll ask Deepika to share the invite related to the project presentation. Okay, so that is probably the assessment two, guys, actually. Okay, assessment two. And of course, we'll announce the best team or best contributor. All these things are as usual. So I need to by tomorrow, friends, just to form the groups and maybe in Slack or personally through Teams, you can update me on your batches. If you are unable to form the batches, then randomly I'll pick up the names and form the batch. But most probably, generally, up to now, the teams come together and they only give the names so that we are having the rapport. Because to design a project of the recently trained technology, definitely the communication and rapport must be there between the members of the team. So I definitely wait tomorrow and day after tomorrow. Just you can give the names. Accordingly, I will share the corresponding capstone projects with you. So you take your time and complete all the documentation, implementation, presentation. That I will give the guidelines, guys, and all those guidelines I will be giving to you once you form the batches. Okay, tomorrow once again, just let me know who are all formed the batches, and in between, if you are already, I mean, just now I am informing by today you could able to complete the formation of the batch, then please let me know so that I can announce 4 or 5 batches initially, and then remaining 3 batches. Either I can suggest to form, or else by tomorrow or day after tomorrow, you people can decide based on your 3 or 4 membership into a complete team or batch, right? Okay. So these projects actually we are referencing to this Spark SQL and data frames APIs because these data frames and RDDs are the basic constructs. On top of that, we are going to apply some kind of the implementations and all those activities. For batch processing on top of the data frames or data sets. As I said, no, data sets are not in Python, they are only in the Scala. Okay, everything can be achieved with the data frame. You need not go and venture again another component, right? And structured streaming API and Spark SQL interface for stream data processing on top of the data frame. We'll see based on the time. Just I'll give one case study on this streaming also, guys. And most importantly, especially in the data science, the advanced learners and all, they can establish the ML pipelines, okay, machine learning pipelines, where pipelines to apply machine learning algorithms on top of the data frames. And graph and parallel computing can be achieved this graphics. See here, so just if you observe, I'm having the Spark SQL support, Spark streaming for the real-time processing, machine learning library for the data science or machine learning kind of aspects, graphics. Okay, and this core, however, is involving the RDD along with the transformations, as I said, transformations and as well as the actions. That is the core of the Spark. So now we study this core of the Spark in today's session, like RDD I'll introduce, and we are going to talk about data frames. And then, friends, before starting RDD and data frames, we'll try to submit the jobs to Aaron. Okay, that's what because related to Mesos, I'm having Aaron with me. Okay, and Kubernetes, all these AWS, EC2, Hadoop, Air, all these kind of the technologies, okay, easily integrated with our Apache. Of course, in the today's session, what we'll do is especially in the Hadoop distributed file system and local file system, how do I access the data from Spark, and how do I submit MR kind of things. Because MR we have seen, now what we'll do is we'll prepare one job, we'll submit this job to ARN. That is one thing. And the other aspect is RDD implementation and as well as the data frame usage. Probably the programmatical aspects now I am going to launch in front of you guys. Okay. So let me see. Should I complete any conceptual thing? Yes. Okay. RDD, actually, I need to introduce you guys because with this RDD only, I can able to continue my journey of giving you. Once this particular RTD is completed, then we are good to go with the appropriate programmatical construct. Okay, hardly 10 to 15 minutes. We'll finish this and we'll jump into the coding construct. Now, if you observe the kind of the data structures, so in PySpark especially, resilient distributed data set, and second is the data frame. Both are the containers or constructs which allows us to perform certain kind of the operations. As I said, transformations and as well as these actions. I'll introduce you which are all the transformations and actions, so that while using itself, you can feel that whether this is a lazy execution or immediate execution. Lazy execution is related to the transformation. Immediate execution is related to the action. Okay. And RDD is a low-level data structure which Spark uses to distribute the data between tasks while data is being processed. Understand this point, friends. RDD. Data structure means, friends, logical arrangement of the data or structuring the data. So this RDD is a logical arrangement or structuring the data which provides is a low level that is memory oriented, okay, which is very closest to the memory of the Spark, which Spark uses to distribute the data between tasks. I am having data 1, data 2, data 3, and I am having some tasks with me. And according to the requirement, task 1, D1 will be distributed, task 2, D2, task 3, D3. That means whatever the data I'm having, these particular data items are distributed to the requirement of the task. Accordingly, RDD is going to venture or handle the appropriate functionality. Okay, and this RDD, as it is low level, all the memory relevant aspects, caching, persistence, and as well as the partitions, all are related to RDD only, friends. Because generally, the constructs which are very nearest to the memory or having all these caching techniques and optimization techniques, especially partitions and persistence. So RDD is having its own kind of the existence. Okay, and coming to the other aspect, guys, this is the data frame, which is a revised version because we are habituated to use the table kind of the data in case of the SQL and all those kind of things. So data frame is nothing but row and as well as the column wise container, which is a tabular representation. So which where you can store the data and process the data in a very flexible manner. So coming to one more point, guys, actually. So just I'm having the Spark, like how Hadoop is having many versions. Initially, they released the Spark 1.x. What they have done is they came up with Spark context. Spark context. Okay, of course, Scala is the basic programming language at that time. And this particular Spark context, of course, having the support of the RDD without fail. And now what other kind of things is in case of the Spark 2.x or 3.x, okay, there are certain demands, friends, actually. They along with the Spark context, what people are looking for, they look for Hive context because they are very happy with the Hive query language, and they asked for the SQL context also. Okay, now what they have done is the designers combinedly they came up with one more approach called Spark session. Now observe, guys, here. Spark context, if I am saying, or SC. In the earlier session also we have used SC dot in Scala. Whereas in PySpark we have used Spark context, if you remember. So if you consider this particular Spark context, which is the initial component in Spark 1.x. But later point of time, as there is a heavy demand from the developers, we need Hive context and we need SQL context. Reason is pretty simple, guys, because the Spark is a super success on top of ARM. ARM, if I am using at that time, MapReduce 2 is the main component on top of the ARM. Alternative to this MapReduce 2, we are having Hive, Scope, and a Hive, if I'm saying, obviously, this is the Hive query language. And of course, some sort of Scoop and Pig Latin. All these kind of things are more or less related to the SQL kind of orientation. So they demanded we need these kind of the context also. So we want to integrate, we want to utilize those kind of the technology. So they came up with one component that is a Spark session. This Spark session supports the Spark context, Hive context, SQL context. Of course, from Spark 2.x, even in 3.x also, if I am using Spark context, of course I can use. There is no restriction on that because Spark context, especially RTD orientation, or still if you are having some of the companies still they are with Spark 1.x. In that case, you should use this Spark context. There is no question of the Spark session. Whereas in 2.x, 3.x, if I am saying, of course, if I am using my Spark session in my code, then you should realize that, oh, this is either 2.x or 3.x. And of course, I can use RGD, I can use the data frame, I can use the Hive context, and at the same time, I can use the SQL context. Okay, all these kind of things. SQL context in the sense Spark SQL. Okay, so Likewise, what they have done is they further simplified the approach of this Spark session. So now coming back to this understanding, so data frame, of course, is created on top of the RDD because RDD is the low-level construct. On top of this RDD, we are having the data frame. As I said, data frame is some kind of high-level abstraction where the data is represented in the tabular format, row and column-wise fashion, which is very flexible to get and process the data. And moreover, I'll show you in the today's session RDD to data frame and data frame to RDD. The data transmission is performed. There is no restriction on that kind of thing. Okay, and let me take a pause here, guys. Okay, so I want to show you some kind of the job submissions where now we are having some sort of understanding or advantage of making use of these conventions. So let us jump into our favorite workspace. Just this particular workspace helps us to go ahead and submit the jobs and all these kind of the conventions. So just a minute. Let me share the convention of using this uh, specification. Yeah. Now have a look on this, guys. Just I'm having the normal web shell and I'm having some sort of programming with me. And I want to submit the job to the app because we were talking about the job submissions and all those things. Now I thought of scoping the session in this way. Rather than starting RDD and data frames first. However, we are having the knowledge of job submission in terms of MapReduce, so that I thought of showing you how a Spark job, okay, how a PySpark or those kind of the code can be submitted to the ARM or Spark or local machine because many kind of things are available. So for that purpose, what I'm doing is just I want to show you this particular file. Have a look on this file, friends. Okay, probably this is the first PySpark application I am showing. Don't worry, just one by one, you can have a look on this, guys. So this particular application, what it does is just it is going to perform some kind of the word count. The first and foremost important point is apart from the imports, okay, just only we are having the two lines of the code. Why I am saying two lines is this is of course very common. Just I am making use of the Spark context and I am naming my program as PySpark word count. And second thing is actually reading of the input file. And last statement is writing the output file into the corresponding folder. Okay. So apart from that, just you can see here I am having the flat map. Okay, flat map, and as well as I'm having some other things like map and reduce by key. So the comparison, friends, if you refer the map reduce code, no matter in terms of the Java, in terms of the Python, at least 15 to 20 lines of the code we observed. But here, if you consider, okay, just with the 3 to 4 lines of the code, and that too, 2 or 3 lines of the code is just we are having to read the data and to name the program and to store the output. Okay, all these kind of the conventions. Of course, these particular coding, however, you can observe, friends, like while dealing with Lambda functions in Python, okay, all these things I'll introduce. But today, what you can see is just I am making use of the Spark context. I am mentioning that I am running in my machine, and this is the name of the program. And as I said, Spark context is something which is ready to perform some kind of the activities. Okay, and I am not requiring any Hive context or this SQL context. Directly, I am using the Spark context only, and I want to perform the reading data, friends. Okay, just I want to give a glimpse. Actually, this particular reading of the data I am performing in this application actually, Hadoop distributed file system. So you pretty know that by default, especially this cluster I'm talking, this cluster, MapReduce, of course, this cluster or any other cluster, by default pointing to the Hadoop distributed file system. Hive also, Hive you can specify either local file system or distributed file system, and Pig Latin also in a similar way. But Spark, generally our Jupyter Hub is Jupyter Hub. If you see here, all these files are from the local file system only, friends. These files are from LFS1, LFS3, like that. But if you observe this example, I have not mentioned any path here. Okay, directly I'm giving the input as email in. This email in is the see here. Just I'm having Hadoop FS-ls. Let me show you where I am picking up this emailing. Yes, this one, friends, actually. Okay, so emailing is there in my Hadoop distributed file system. Just now we have seen. So in this example, I am mentioning that I am making use of this emailing file, okay, and store that file in such a way that actually flat map, what it does is, friends, if you remember correctly, after loading of the data into the Hadoop file system, the first important thing is it is going to split the data. Okay, split the data into the key value pair. So here what we are doing is with the help of the flat map, whatever the data I'm having, the data based on the space, because I want to separate the words from the statement. Word means after completion of each word, I'm having the space so that it is managing that. Lambda is the inline function. So this particular lambda function, what it does is just it is within the same line, the corresponding code is going to execute. If you observe, friends, in case of the functions, we are having some bottleneck. Bottleneck in the sense, suppose if the function actual implementation is taking 2 seconds, and calling the function, again going to the function call, implementation, again getting back the function to the main or the called function. These activities compared with the actual execution, the other activities are gaining more time. Okay, they are requiring more time. So in that particular case, they invested on this lambda function. Okay, so this lambda function is which is a construct where if I want to run through, okay, if I want to perform some kind of the operation within the single line with the inline orientation, then I can do with the lambda function. So finally, this particular statement, what it does is it is performing. Actually, this is a pipeline, friends. Here I have read the input file and I split the corresponding line into the words. Okay, pipeline of activities. And the data I have stored in the words. Okay, so what we are doing, read data from text file and split each line into words. Okay, and next, coming to the next one, count the occurrence of each word. So now I want to convert this particular thing in such a way that, okay, map is a function where it is going to apply to each and every statement in the file. Okay, what we are doing here is pick up a word just to convert that word into key comma value, word comma one, and reduce by key. This reduce by key, what it does is, suppose if any similar kind of the words is there, okay, similar kind of the words is there, it is going to count all those repeated words. Suppose Hadoop appears 5 times and Hive appears 10 times. So based on the commonality, it is going to compute this particular addition. Okay. So based on the repeated words. Now this word counts, whatever I'm having, just I'm going to store in the text file. Okay. Just will be storing into the text file. So now observe here, friends. Maybe I would have ran this particular file earlier. So what I am doing here is Spark output. Just for our sake, I'm using HDFS1. Okay, like that I'm changing. And observe that here my input is from the Hadoop distributed file system. So it proves that in this current program, we are using the HDFS as the input file. And of course, obviously HDFS as the output file. Okay, so after completion of this particular code, I should verify my output in the HDFS only, not in the local file system. Of course, Spark supports both local file system and Hadoop distributed file system. Now observe here, guys. What this import is? Import is related to the system kind of the functionalities. This is the statement where we can generally use, guys, even in our RDD or data frame, the very first statement is from PySpark.sql import Spark session. But now you see, guys, we are only using the Spark context. We are not using any Spark session or something. So what we are doing here is from PySpark, I am importing this Spark context and as well as the Spark configuration. Now, in case of the Java, we are having public static void main. And now in Python also, just I want to mention, okay, I want to mention that here I am writing the driver code. Actually, this code is known as the driver code or main code. So according to the requirements of this MapReduce and as well as this Spark word count kind of thing, just we follow the same kind of the approach. And one more important thing, guys, as Python is not having any kind of main functions or some sort of variable declaration, all these things. But from RDD and data frame, we may not use these if name, main, all these kind of the conventions. But why we are following this approach is as we are learning or as we are having the background of the MapReduce, in the similar way, on top of that particular MapReduce, we are trying to submit our job through this path. That's what we are following the same kind of the convention and approach. Okay, this particular program, okay, we have observed and just how to save this thing. Just you can escape, press escape. It is taking some time, guys. Just we wait, and then you can give this shift colon. Yeah, now I can give this shift colon WQ writing and as well as the quit. Now we are having our wc.py. This is the source code. Now be with me, guys. How I submit my job to and Spark submit. See, guys, Spark submit. What is my master? My master is let me submit my job to the ad. Okay, I am submitting my job to ad client. Okay, add client as a from the client mode. Just I am submitting to add. And what is my deploy mode? So just I can make use of the deploy mode. Deploy mode also. Deploy in the sense where do I get this outcome in the client only? And what is my program? wc.py. Okay, just have a look on this, guys. How simple it is. So in the earlier submissions, maybe in case of MapReduce, with the help of the Java and Python, we need to have that Hadoop jar file name, package name dot driver class name, input and as well as the output. Now in Spark, it becomes quite handy compared with that particular approach. And this in the program itself, I specified the input data item, and in the program itself, I have specified the output. So there is no need of mentioning the input and as well as the output. Next option is where is my cluster and from where I need to get the resources. For that, I am instructing my cluster in such a way that hey, just you can give this Spark submit. Okay, I am submitting a Spark job, and my master is ARM client actually. So this on top of this ARM, actually I'm having configured with ARM also on this cluster so that we are submitting our job to this ad and deploy mode. Okay, this particular deploy mode is the client, and here just what we are doing is wc dot. Is a bit slow, guys, or else we'll go to this thing and clear. Just a minute. Just will clear this thing. Yes. Now Spark submit. Okay, Spark submit. My master is ARM client. My master is add. And then what is the deploy mode? Where do I deploy this thing? Deploy mode. This is also client. Just you can make use of wc.py. Let us run this code, guys. See, just it is performing and it is quite faster. No doubt about that. There is no map. There is no reduce. Done. Completed. So this job 00008 committed. Okay, 3008 committed, and then it is giving us all these kind of things. Successfully stopped Spark context and all. Now what we are doing is just we'll go back to this thing, and I'm having the Cloudera manager portal. Okay, so just to remember what is the name of the job, 3008. Okay, so while launching this thing, let me access this thing, guys. Let me show you in Hadoop fs-ls. I'm having Spark output HDFS1, this one latest. Now we have executed that. Okay, now you just to give a clear thing, Spark output underscore HDFS1. Now what I'm doing here is Hadoop fs-ls Spark uh, output HDFS1 slash. Let us see, friends. Same thing, success, whatever the data. And if you remember, friends, properly, um, while getting the map reduce outcome, we have seen some multiple parts. Part 0, part 1, part 3, part 4, because they're all parallel. And writing the data from disk to map reduce and map reduce code to disk, like that we're having actually. So reading and writing from disk to map reduce is very frequent. In Spark, it's not like that. That is the reason it is maintaining the entire data in a singular file. Okay, so now in the Hue login portal, just you can see that our Spark output, just I need to refresh, Spark output underscore HDFS1. This one, guys. Okay, just to click on this. And success, of course, which indicates the uh, appropriate successfulness of the program, and you click on this, obviously you will be getting the appropriate content. So department was used 2311 times, off used these many times, state, case, all these kind of things. So like this is giving us some sort of understanding how many times the appropriate members used the statement. Maybe any negative feedback, or because just like that people are writing, and I want to get to know whether what about they are talking, because across the appropriate supermarket, maybe if I'm considering this input file is a mail written to the manager actually. So multiple managers were there, and they provide us this particular input data, and we need to come up with the implementation of the word count. If any such negative appreciated, only two times we got unclassified 1009. Like that, we are having some sort of understanding. Okay, so based on that, we can clear okay the issues or the problems at the high level. Okay, at least in a high level way, we can understand the whether we are going in a proper way, or is there any issue related to that. All these kind of the consideration, right? So now, here 2 points, friends. One is just like we have submitted the job, and we have picked up that information, and that particular job submitted to the ARN cluster actually, and we did observe the outcome in the distributed file system. Okay. Now the leftover aspect is so actually my name of the job is 3008. Now I'm going to this Hue or Hue Cloudera Manager portal, and from that I want to check whether I should check in the ARN or Spark Friends. Both will check. First we'll go to the ARN. We'll give the ARN first preference, and here I'm having the web UI history server. Na? Just you can click on the history server because already the job has been completed. Now I am picking up this information. Let me just you can refer this kind of thing. You can manage do this. Okay, because we are checking on ARN friends, not on the Spark. Spark will check now once this is completed, because this is a two-step process. ARN as a cluster manager, I'm having it. Okay, so just to refresh, I cannot see any uh, big data mind one kind of user. So ARM is not tracking, however. Okay, that too, if you see the these kind of thing, nothing is there. Okay, so let us click that once more. Yes, it's not there. Okay, no problem. Let us go back and see the resource manager. If any resource manager support is there. So just what I am doing here is web UI. As I cannot see anything related to my job in history server, I want to see in resource manager the same consideration. And just you can give this. Now I am checking in the resource manager. Is there any possibility of tracking my job? Here also it's not showing guys. Finished job because my job is already done. Here also it is not giving anything guys. Okay, so at least we are not having anything related to our job. Okay, here also not tracked. Now what should I do? My only possibility is I should go to the Cloud Era Manager. Okay, I should go to the Cloud Era Manager. I'm having the option of the Spark. Click on that and history server UI. That is the Spark UI, friends. And same thing, same. And they ventured. They have given this approach, like they have given us the possibility of accessing the resource manager, history server, all these things. Ports are different actually. Okay, compared with the resource manager port, history job history portal is port is different. Okay, so now you see, guys, in the first line itself, I am seeing the big data mind one, and the duration is 6 seconds. All these things, PySpark word count example. Actually, this particular intentional, I have given the mistake here. As it is, okay, we are giving this, we are seeing this thing, whatever the program wc.py we are having, and then okay, just we are clicking on this because in the statement itself we have given that local. That's what it's showing as local. And if you click on this, guys, actually this is these are all the jobs and DAG. As I'm having the text file reading first, and I'm partitioning, map partitioning, we are mapping, and finally we are saving the file. See, just now we executed that thing, friends, and it is showing us some sort of DAG actually. So DAG is something like which is a directed acyclic graph. I need to give some more information, but see here, we submitted our job to the cluster, and as a result, we are having this particular representation. How our job is split into the stages, and each stage again containing some kind of the activities. If you observe these guys, if you observe this diagram, just it is giving us the narration of how it is splitting the appropriate job into the stages, and how each job is again having some sort of task. Okay, so here it is logically showing the information, the text file. Okay, if I'm clicking again, it may give me some kind of the insights. And then along with that kind of things, which are all the constructs I have used. And thereafter, yeah, internally it is using the day two method, and like it is performing some kind of activities with RDD and the metrics related to these kind of the considerations. So here, if you refer these kind of the understanding friends, have a look on this. Just I am making use of this convention. Okay, even I am pasting in the chat window also, so that you can have a look on that according to your requirement. Uh, this DAG gives that in what way we can optimize our job. Okay, because some of the constructs may be taking more kind of the timing, and some might be taking less time. So that based on the kind of the requirement, I can optimize the things. And of course, as a developer, you need to keep an eye on this, guys, because these kind of the things definitely give the understanding of how we can optimize the aspects, and you need not worry about the other kind of the resources and how we are using and how much time and all. But only the thing is how I can manage, how do I make use of the better optimizations. So for this particular thing, just I can use this DAG kind of the approach. So DAG visualization gives us the approach, which are all the constructs I am using, and in what way we are performing the activities. Okay, these things can easily help you in the study of, in the observation of how our program is performed and which are all the constructs internally managed, all these kind of things. If you go to the detail, it gives some sort of running of the job, all these kind of the things. Okay, so just in your this thing also, virtual machine also, you are having this approach, guys. Okay, maybe with local host and 180.88. If you go to that particular web-based interface, definitely you will be getting the outcome. And event timeline, so which gives us how it is spending time and on what basis, okay, it is performing, whether how much time it has taken by reduced by key, and while running the job and execute driver. Okay, here each and every job is having some executor. Executor is nothing but the task tracker kind of thing and node manager kind of thing. But in the Spark, we can say that as the executor. Okay, so the observation here is that we have taken some kind of the code. Okay, and that particular code we have submitted to the ARN cluster. Now we can observe the way we are performing the activity in the job submission, and after that we have verified the Hadoop distributed file system, and then we have seen the ARN cluster. The ARN cluster could not track the appropriate job history, and in the resource manager also, only it is providing the cluster management. Okay, but the Spark, in the Spark web user interface, I can able to track my job, and I can observe this DAG and all these job allocations, all these kind of the conventions. Now let me show you one more example where I created for us. So one more example I'm showing to you guys. Now, if I want to pick up my data from the local file system, okay, I want to pick up the data from the local file system. Coding is same. Starting from the first line, if you observe, I'm importing the sys, and from PySpark, just we are importing Spark context and Spark conf. And as we are running through the MapReduce mode of the submission, so the same kind of the driver code I'm mentioning. And here, just we are managing the configuration. Okay, Spark context. Just I can change this thing. Uh, just I can give this example. PySpark word count example with LFS. Okay, with local file system. Now, friends, here one important point is as by default, our Spark engine depending on the local file system, depending on the Hadoop distributed file system. Now I want to access the data from local file system. Okay, so just you see here, clear, clear the screen. So within this, I'm having some sort of the file with me. Let me see what exactly that file is. So here. Or else let me open one more website by simply wasting time. Yes, clear. And now, LS if I'm giving, I'm having my local file system. LFS1 is there, that file is there. So I confirmed that this LFS1 is there definitely from the local file system. Now I'm giving a try. Okay, so of performing all these statements are same. Just I'm splitting the line into the words and I'm saving that thing into the words and word count with the map. Map is a functionality where it is performing all the activities on each and every word. Okay, all that whatever the activity I have mentioned, just I am taking the word, just I am converting that word into the key value pair, and thereafter we are reducing that in terms of adding the repeated words. And I don't want to save the file in the Hadoop distributed file system. What I want to do is just I want to mention my Spark output. Okay, I want to store in. Let me give you the because we are following one convention, uppercase letters. Okay, at least in this demonstration. So just you observe that reading of a text file, maybe from the local file system. Just what I am mentioning is I am clearly mentioning that the entire path file, three slashes. Again, the fourth slash is slash home refers to the local file system. Slash user refers to the Hadoop distributed file system. While mentioning in the Jupyter Notebook or Jupyter Hub, especially in this way, friends. Okay, so if you see here, as I want to, yeah, this thing also, I am clearly mentioning the from the home folder I want to access, and thereafter somewhere, yeah, this stock one, stock one is not there in the local file system. This is in the Hadoop distributed file system. So by default, this is also pointing to the HDFS orientation, right? So similar way, here what I'm doing is this Spark engine is expecting the default location as the Hadoop distributed file system. So let it be. But my interest is can I access the appropriate information or input data from the local file system? So what I have done is just I'm pointing to that local file system by completely giving the entire path. And from that particular path, I'm picking up my input data item. Okay. So just let me save these changes. Now I need to submit the job. How do I submit the job? Same thing, Spark submit. Okay. And my master is add client, add client. And then deploy mode. Where do I deploy? The client only. And finally, friends, I should give the wc1.py, whatever the code I want to run. Okay, wc1.py. Just to enter this. Okay, so just it is the same way how we have submitted earlier. No matter whether I'm using the HDFS or local file system, our ARN is having the capability of accessing the details from that. Okay, so simply it is running and it has given some kind of the code. Okay, so just we are making use of that convention. So just go back to this Hue login, and Hue won't consider this LFS Spark output LFS. Definitely not. It's not containing Spark output underscore LFS because this thing we explicitly mentioned that I want to get the data from the local file system. Okay. Now what you can do is just you clear the screen and you view this ls Spark output LFS1. So what I'm doing here is ls Spark output LFS1. See here, Spark hyphen 5 zeros. Now I can cat Spark underscore LFS1 Spark 5 zeros. Okay, likewise, I can easily, it's a small file only, friends. I don't want to give the heavy file from the local file system. Maybe I want to get some sort of understanding whether this local file system approach is working or not. For that purpose, just we are giving this convention of accessing the data. So this is another way. Okay, like only ARN I am showing. So Spark, just I am submitting my job to the Spark ARN cluster manager. So that ARN is supporting us to run this particular code. However, from the PySpark HTTP web server, one can easily go back and verify how this particular job took time, and even you can compare from the HDFS how much time it has incurred, and from LFS maybe for the smaller jobs or for smaller inputs we may not venture this, and I strongly recommend you, and earlier I suggested you to download the wiki page counts, just to have a look on that and you can execute the same word count application with your wiki page count. And even here also just it took 6 seconds, and from your LFS it took only 5 seconds. itself it is showing that you can run your job on AND rather than depending on the Hadoop distributed file system. I can able to reduce my number of seconds. Okay, compared with the HDFS, LFS orientation is giving the less amount of the time. That there you can realize that thing. Whereas in Hadoop MapReduce, because HDFS is the native directory and native storage for the MapReduce, always, even in Hive or in Pig Latin or Scoop, by default, that HDFS access is native to that, so that we can register, we can measure all these kind of the functionalities took less time when compared with the LFS orientation. But here the point is not like that. Here the point is Spark is seeing HDFS and LFS equally. Those Spark is in this cluster. Actually, Spark by default is looking for the Hadoop distributed file system. Whenever you are not giving any path, by default it is going and seeing into the HDFS. But whereas if you are quite interested to give the input file and as well as the output kind of thing from the local file system, just you can make use of that convention. Okay, so this is how you can refer. Okay, maybe you can change your input data item. I'll be pasting all these codes with you guys, and just have a look on this. As easily you can submit this job, and you can see one bigger file. Like as I said, that Wikimedia wiki page counts. Maybe in GBs we are having the data. Just to have a look on this, just to download the data with the help of WinSCP, you can store the data in LFS and run the code and estimate the time with the help of the PySpark web user interface. Similarly, just to pick up the file directly from Hue login portal, and you run your PySpark just by changing the Hadoop distributed file system. Okay, so just to give that input data. Then thereafter, once the two programs were executed, have a look on that. Okay, how do you how these local file system, how much time it took, and in case of the Hadoop distributed file system, is there any lag or is there any benefit of using this HDFS or LFS while submitting the Spark, especially in this job? Okay, in this particular application, we can clearly observe that our job, okay, whatever we are talking about, that particular thing is better finished with local file system rather than the distributed file system. Okay, and some other options I want to show you guys. Just I want to give you one more this thing. Let us see what I have done. Yeah. There is a third option always comes to your mind now. So what happens if I am reading my file from the local file system and I want to store my file in the Hadoop distributed file system? Let us see how much time it is going to take and what exactly the duration and all these things. Here the narration is pretty simple. Just what I'm doing here is as usual importing PySpark usage and reading of the file here. And what I'm doing here is guys, Spark word count example, LFS, HDFS combination. Okay, so that you can easily recollect it. And now I'm picking up the same data, LFS1, um, so that I can see whether the earlier example, how I can, and one more thing, friends, actually. If you remember, email in is having bulk data. While submitting with the Hadoop distributed file system, I have given the email in, but while submitting in the local file system, I have taken very small file, LFS1. So maybe that is also the reason why LFS took less time when compared with the HDFS. Based on the data also, it decides, no? Because that is a heavy data. It is only having some 20 lines, 20 records only. There I am having some around 10,000 or 20,000 records. Okay, so that is also playing a key role. And remaining, what I'm doing here is just I'm making use of Spark output. Uh, this storage, of course, HDFS2. Earlier we have seen that. HDFS1 we have seen. So I am storing this file WC2. Okay, so now Spark submit. My master is, of course, ARM client, and then my deploy mode. Deploy mode also, in the client mode I am deploying. My file name is wc2.py. Okay, now we can have a look on the time factor and all these things. Just it is running through. Done, completed. So immediately we'll go to the history server. Only these two are there. Okay, now you refresh on this. Same logic, but only the thing is this time I am accessing the data from LFS and I am storing the data into HDFS. No change, guys. No change. Same 5 seconds and as well as the 5 seconds. Okay, maybe you can venture that both from the HDFS and HDFS. Then what should I do? Then go back to this thing, clear the screen. Okay, just we have to observe these points, friend, because these are all the points which really helps you in the orientation. So what I am doing here is Hadoop FS hyphen put whatever the file I am having LFS1. Just I am storing to HDFS1. Maybe if it is okay. Now again I need to change the wc2.py. What should I do? I want to read the data from HDFS. So let me I need to remove all these things. I should give only HDFS1 simple, and here output folder I should change, otherwise it won't allow the same. Now just let me save this and Spark submit. So this time we are using the HDFS as the input and HDF as the output. Maybe not much distinction you may observe, but the possibility I'm saying Spark submit hyphen master. In between it is taking some pause, right? So, yeah, let me see here. Spark submit hyphen master. My ARM client deploy mode. What is my deploy mode again? Client mode wc2.py. So just to observe, our interest is to estimate the timing and all, and maybe you can see in between also, guys. Like you know the what is the timing it has taken. Here also it is providing some kind of the knowledge for us. Just have a look on that. Okay, so all the existing things I'm having. Now you refresh on this. I did not change that LFS HDFS name remains same, but only the thing is my interest is there any distinction of observing the job? No distinction, friends. Okay, so but only as you know, a very simple data I'm giving. If I'm giving the heavy data, then I should verify. Do I have any change in bulk data? And all that I'm leaving to you as a task kind of thing. You can venture that. And moreover, some other options are also available, friends. Spark standalone is there actually. The same application, you know, let me clear this. What I can do here is only the thing is now I need to change the output directory. Nothing I want to change, but what I want to do is I want to change this output directory only because I want to show you this is not the point actually where I'm accessing the data, where I'm storing the data. That is not the point. Up to now, just we have seen picking up the data from HDFS and storing the data into HDFS. Second thing is picking the data from local file system, storing the data into the local file system. Next option also we have seen picking the data from the local file system, storing that into the HDFS. These variations, probabilities we have seen. That is there any distinction? That no distinction is there. All jobs took only 5 seconds. There is not much differentiation. But now what I'm doing here is, guys, my interest is As you know, in case of the job submission, not only ARN, but other options are also there. If you see in our this thing actually I have shown, let me show you that. Spark is, yes, I got it. So Spark is supporting, uh, ARN it is supporting, Mesos is supporting, standalone it is supporting. Okay, see here, standalone and all these kind of the things. So my interest is how do I submit my job? Suppose if ARN is not configured, it's not a rule. No? Every time our company may not interested on ARN, and maybe they are only giving the standalone or local mode of the submission. Then as a developer, you should know that how do I submit my job into the other than ARN. So for that thing, just I'm having certain considerations friend for us. So just you can make use of Spark submit. This remains same, and I need to mention the master. Earlier I used to mention the master as the ARN. Now I am mentioning Spark is also a cluster management tool, friends. If you observe in the definition of the Spark, Spark is a cluster management framework. That is the first statement. So just I am directly using Spark and I am making use of my deploy mode client. Okay, so just two times it got. Just let me remove this. Okay, my deploy mode is client and I am making use of this program WC2.5. Just have a look on this. Instead of the add client, I am directly mentioning my Spark engine only. Spark is having its own capability to run the task. So now you enter this. Okay, so as usual, it has taken some kind of the time and it is running through. That's all completed. Okay, now go back to this history server and you refresh on this. Now this time I may get some sort of less amount of the duration. So even I don't know because very less input we are giving. So but still, okay. So see here, all these latest the current thing is just this is the program we now executed. And now what we are observing, the same kind of the duration, all these things. Maybe internally we can observe the distinction, like in terms of number of tasks or in terms of DAG scheduling. Okay, you can venture all those research and you can come up with some analogy, friends. Even I want to give some task to you. What is your observation on that? Even in project also, I'll mention that point. So because after observing all these submissions and if you could able to refer, okay, how do I get some sort of information and based on the timing and as well as other optimizations, you can maintain some benchmarking trend for that. Okay, so in a way, if you once you implement these things and once you are having evidence of okay, if I'm using local file system input and output in the HDFS, I am getting some 2 to 3 minutes less amount of the time in the job execution. And similarly, the DAG also somewhat it is having the less pass. It is avoided some other pruning with the help of pruning or avoiding of some of the paths or tasks. It can able to perform the activity or job. So this way you need to analyze friends actually. So otherwise the job submissions and understanding of the coding is pretty simple. Only the thing is optimizations as a developer. Okay, just you need to we are having your cluster and you are submitting your job. And after submission of the job, all these things you can estimate. And the same thing you can replicate related to your projects also. Okay, the main benefit here is guys, 60 to 70 percentage of optimizations are in your code only. Okay, by default, however, we have seen in Hive, the partition itself is the optimization technique while using. Similarly, in case of the Spark or PySpark, whatever, so just you while managing this LFS kind of thing, HDFS kind of thing, or submission of the job to the ARM or Spark, or these kind of the things definitely helps you. there are certain possibilities to identify and handle the certain constructs. Okay, this is how you can see and refer the orientation of job submission related to our Spark. And one more option is there, the last option. Okay, that is the local mode of the submission. Okay, so now let me give this thing because I cannot use the same output directory. Okay, so I'm making use of this thing as some change. Let me save this. Now the other way of submitting the job, Spark Submit. Okay, Spark Submit. What I'm doing here is my master. Earlier I used that add client and latest I used that Spark. Now I'm using the local. Okay, some local or standalone kind of thing. Deploy mode. Some people, guys, even they don't install Hadoop or ARM kind of thing, and they just they're happy with their Spark, RTD, and all these kind of things. For them, it is quite handy. Okay, so you download the appropriate software from the Apache, and you install that Spark, and thereafter you are not having any HDFS or nothing is there. Only directly you are mentioning some kind of local file system, and you are pushing the data into this Spark program and outputting the same to the local files. That is the scenario. Assume that no error, nothing. Okay, nothing is there. So in that case, you can use either Spark mode of the execution or the local mode of execution. Okay, your deploy mode. Just I am mentioning the client and the same program. Okay, so just you see here. How do you prefer that? Okay, so just I have completed successfully. Now you go to this refresh. This time I use that client, this local mode actually. But either way, guys, either way, maybe I'm submitting the app, maybe I'm submitting to the Spark engine, or might be I'm submitting to the local. But in all the ways, the procedure is same. Only I am changing the appropriate mode of the whether ARN or Spark or local. But if you observe this, guys, we did not change anything except that output. It took only 4 seconds. That means definitely there is some uh, bottleneck is there, especially in your POC kind of the projects. It is always better to submit your job to the local rather than ARN or Spark. It is giving some sort of less amount of the time. Okay, you can clearly see this. So if you refer this particular thing, all these jobs are ours only up to this. Okay, so up to this our jobs only. And what we are doing is we are making use of the convention. Okay, whatever the event log and all those kind of things I'm having. Just I'm posting this to the chat window so you can easily refer. Okay, we can submit the jobs in various ways and we can perform the activities. Okay, so this is how you submit your job, but this may not always the case, friends. Maybe the people who are having the Hadoop inclination and maybe they are trying to run their jobs other than this MapReduce, they want to convert their programming into PySpark, their code, and they use it to submit these things into this. Only these specific applications are having the approach. Why I insisted to learn this particular aspect is, in a way, Spark provides various kinds of the approaches, and out of those kind of the approaches, let me give you the way how we are submitted the job to the corresponding app or Spark or client mode. Okay, so the Spark job submission to first we can submit to the ARN client, all are small letters only. Next, we submitted our job to Spark. and then we submitted our job to local. Okay, of course, some other options are also there. Mesos is there, and other cluster resource management is there. But in our cluster, we are having these three. Now, coming to the first one, how do I submit my job? So, in the web shell, Spark submit. Okay, Spark submit. Just I need to give the master. My master is and client. Okay, continuation friends. No need to come to the next line. My deploy mode is also client. Now I should mention the corresponding program name, wct.py. Coming to the second one, this is of course ARN based. Okay, ARN based. Now the Spark based submission. Okay, have a look on this guys. Spark submit. This master remains same because we have to inspect Spark. Just I'm using these possibilities. My master is Spark, small letter friends. My deploy mode, no change. Deploy mode is also client. Now I can mention this wc2.py. So the third possibility, local mode. So this local mode, what it does is Spark submit hyphen master. I can give local deploy mode client wc2.py. This is how you can refer the way of the job submissions, because these are all the various ways. As our cluster is very rich and we are having all the luxury of submitting to air or Spark or local mode. But maybe some people like Vedant, they would have installed their own Spark engine. Then they should go with the local mode. Some people like, Harish, they might have installed the virtual machine. They can go with Spark and ARN both. Okay, these three actually works for those guys. Okay, so other than these two, I'm having this AWS Cloudera cluster. So that because Mesos is not there in our cluster, so we limit ourselves to these three submissions. Okay, just by changing the convention of the submission, one can easily observe how do I rate these kind of conventions. Okay, so now let me give you the key takeaways before the break. And once we came back from the break, I'll introduce you the very simple and excellent topic RDD. Let me start with key takeaways before the break. Very first thing is just I started with Spark, which is supporting many programming languages, supporting Java, R, Python, Scala. It's not only supporting the language, it's also supporting various cluster management tools. And just now we have seen. Now it is easy to connect friends actually. Spark local. These 2 points we have seen. And coming to the next point, Spark SQL supports the ML library. Okay, all these kind of the conventions. Second important thing is, let me go back guys. We are revolving around these things now. That's what I could not fetch back. Yeah. These things already we have seen. However, ease of use, all these in a single liner we mentioned that fastness, of course, fastness will report. And this thing also we have seen in a single liner. project discussion we had, no problem. Tomorrow you can reveal your afternoon also, whenever you discuss with your teammates and give me that. RDD and data frames I have shown. Okay, so that one will. The second thing is I introduced the RDD, lower level of abstraction, and thereafter we observed the data frame, which is a construct row and column wise fashion. The data would be stored. This thing we have seen. And one more concept I specified, friends. If you observe Spark context, Spark session. In Spark 1.x, we are having this approach. Whereas in Spark session, I can integrate Spark context, uh, Hive context, SQL context. Okay, so these are all the references how you can make use of the Spark context and Spark session. Now, latest, while submitting the things with Spark Submit, either you can use the LFS input and LFS output, or else you can use the LFS input and HDFS output. Third thing, HDFS input and HDFS output. We have not checked what happens if I am giving the HDFS input and LFS output. Okay, now I am giving you a task. This task is check the job submission with huge data. Okay, in all the four combinations, LFS input, HDFS input with LFS output, HDFS output. This thing, this thing. Okay, total four combinations. That is the first thing. Second thing, observe the time factor in Spark Submit with Spark Submit with first thing is ARL mode. Second thing is with Spark. Third thing is the local mode. Again, that huge data you take and observe these two aspects. And thereafter, we observe the appropriate job history in the Spark Web UI. Okay, here I am having my information related to the appropriate job, and you can easily observe how do I pick up the data and all these kind of the conventions. I'm taking a pause here, friends. Just if you're having any doubt, please let me know. So we are seeing aspects like on top of our learning, just we are venturing these kind of the conventions, so that which really helps us to uh, gather the requirements. Um, and of course, according to that, if I'm mentioning at one last option, however, we are just within 2 minutes to clear the screen. I want to verify WC2.py. How do I store this thing? Because HDFS I am accessing. What I'm doing here is let me insert. Um, this way /home slash spark output LFS like this I'm giving friends. Okay, just I want to fulfill this thing also because all the other three possibilities we have seen except this one. Okay, we should see whether it allows or not. Let us see. It definitely allows friends, I think, because uh, generally in some considerations, Hadoop admin can give you the file name. You need not see that file. Only the thing is your activity is to submit that particular file to the job. That's it. And of course, the output you need to verify whether that output is proper. And Hadoop admin may not have the knowledge on how to run that and all. Admin activities completely to see access matrix and whether if any problem is there, we need to verify that. Only these kind of things. As a developer, we need to observe what exactly the outcome and all these kind of the things. Now what we are doing is we are picking up some data. Okay, this time rather a simple thing. I want to let me go to the simple thing. Okay, for the sake of understanding of the timing. Bulk data also we are having an email in like that. Okay, so but no problem. Just let it be. And so in under the same conditions, is there any chance of reducing the time factor? That's what we see. Now just you save this file and Spark submit. Hmm. Okay, so master. Let me give the ARN only and client deploy mode. Again, client I'm using wc2.py. So just I'm making use of this Spark submission master ARN client deploy mode as usual. So just I'm running through. Some more thing actually cleaned accumulator, something it has pushed up friends. Earlier it's not like it's not there if you observe. Okay, some modification is there, it seems. Okay, now however the job is successfully completed, no problem. It has successfully stopped that. Again, we should go to this, execute this one, the latest running. The latest, and it is also taking 4 seconds. No matter whether you are storing the data into HDFS or LFS, there is no objection at all. Okay, but definitely, um, and now the point is, I submitted the job through ARN only, friends, not the local mode actually. Earlier, I am under the assumption of, under the impression of, if I am submitting my job to the local, then I can reduce the timing. But now, surprisingly, even I am submitting with ARN also, it recorded the same time. Maybe something is there related to the input and output kind of thing. Input, if you are giving from HDFS and storing in LFS, it also recorded the less time. That's what I said. You need to venture it out with various probabilities, just as a tabular representation. In the rows, you can mention air, park, and local, and in the first column you can mention HDFS input, and in the second column HDFS output, third column LFS input and LFS output. Now the combinational wise, how much time I am having and all the least timings you can fetch. Okay, so maybe LFS input, LFS output on top of the local recorded the less amount of the time. Okay, so such kind of the conventions definitely helps us to narrate or to observe the appropriate aspect. Okay, so that's all, guys. So just we are now we can have a break. Just to be back by 12:20. Let me switch on this Google timer. so that we can have a look on this. Right. Google timer. So that we'll see the most required and awaited aspect, that is our RDD. RDD will see some one or two examples, then we can have a look on the remaining things.